Ever wondered if time travel is possible? Let's dive into the mind-bending theories that could make it a reality. From H.G. Wells' Time Machine to the cosmic voyages in Star Trek, the idea of traversing time has captivated our imaginations for centuries. Scientists have been grappling with its possibilities, exploring the very fabric of space-time. Join me as we journey into the realm of Einstein's theory of relativity, where time is not a constant, but a dimension that can be stretched and squeezed. Alright, so you think you understand time? You probably see it as a straightforward, linear progression. It marches forward, seconds turning into minutes, minutes into hours, hours into days, days into weeks, and so on. Simple, right? Well, not so fast. Einstein's theory of relativity threw a cosmic wrench into our understanding of time. He proposed that time is not a constant. He said time isn't rigid, it's more like a flowing river, speeding up or slowing down depending on where you are and how fast you're moving. Imagine a river that flows at different speeds in different places. One of the craziest implications is time dilation. This means that time can stretch and compress. Imagine two twins. One stays on Earth, the other blasts off at close to the speed of light. The twin in the spaceship experiences time more slowly. Time slows down for the twin on the spaceship compared to the one on Earth. This isn't just science fiction, it's been proven with precise atomic clocks. When the spacefaring twin returns, they'll have aged less. This phenomenon is known as the twin paradox. Gravity also plays a role in this cosmic dance. The stronger the gravitational pull, the slower time flows. Near a massive object like a black hole, time can almost come to a standstill. Think of a giant rubber sheet with a bowling ball in the center. That's gravity warping space-time. The more massive the object, the deeper the dent. Time, as we know it, is an illusion, or at least a very fluid concept. It's not the same everywhere and for everyone. So next time you glance at a clock, remember it's not just ticking away uniformly, it's part of a much more complex and fascinating tapestry. Let's talk wormholes. Cosmic shortcuts that could potentially sling us across vast distances of space, and maybe even time itself. Imagine space-time as a piece of paper, folded in half so 2 points touch. A wormhole would be like punching a hole through the paper, connecting those 2 points directly. These tunnels, if they exist, are predicted by Einstein's theory of general relativity. They could allow us to travel vast distances in a blink of an eye. Some physicists believe wormholes could also act as time machines. Imagine entering a wormhole with one end near a black hole, where gravity warps time significantly. You travel through the wormhole and emerge at the other end, potentially in a different time period. While mathematically possible, wormholes are still very much theoretical and incredibly unstable. The study of wormholes pushes the boundaries of our understanding of the universe. Let's talk about the Tipler cylinder, a concept that could potentially unlock the secrets of time travel. Imagine a giant cylinder, infinitely long, spinning incredibly fast, close to the speed of light. This spinning cylinder, proposed by physicist Frank Tipler, would create a phenomenon called frame dragging, warping space-time around it. These curves could potentially allow us to travel through time. Building a Tipler cylinder would require an insane amount of mass and energy, beyond anything we can currently fathom. Plus, it would need to be infinitely long, which presents a few logistical challenges. Even if it remains theoretical, it's a testament to human imagination and our pursuit of understanding the universe. Hold on tight, because we're about to dive into the fascinating world of cosmic strings. These enigmatic entities could hold the key to understanding the very fabric of our universe. Cosmic strings are hypothetical, incredibly dense, one-dimensional defects in the fabric of space-time. They are thought to be remnants of the early universe's chaotic birth, formed just fractions of a second after the Big Bang. Imagine space-time as a smooth surface, like a calm lake. This serene image helps us visualize the concept of a perfectly uniform space-time. Now picture a tiny crack or wrinkle on that smooth surface. That's a cosmic string. These wrinkles are incredibly thin, yet they disrupt the uniformity of space-time in profound ways. These strings are incredibly thin but pack an enormous amount of mass. Imagine something thinner than a human hair but with the mass of a mountain. That's the kind of density we're talking about. Due to their immense mass, cosmic strings would warp space-time around them, creating strange and fascinating gravitational effects. This warping could potentially alter the paths of objects and light passing nearby. One intriguing possibility is that cosmic strings could act as gravitational lenses, bending light around them. This effect could magnify and distort the images of distant objects, offering a unique way to study the universe. Some physicists believe that if two cosmic strings were to pass close to each other, they could create a warp in space-time so extreme that it forms a closed, time-like curve. This could theoretically allow for time travel, a concept that boggles the mind. Despite their fascinating properties, cosmic strings remain hypothetical. We haven't directly observed one yet, but scientists are on the lookout, using advanced technology to search the cosmos for any signs of these elusive entities. Manipulating these cosmic powerhouses would require a level of technological prowess far beyond our current capabilities. The energy and precision needed to interact with cosmic strings are staggering, but the universe is full of surprises, and who knows what the future holds. As our technology advances and our understanding deepens, we may one day unlock the secrets of cosmic strings and harness their incredible power. Let's dive into the grandfather paradox, a fascinating concept that has intrigued scientists, philosophers, and storytellers for decades. Imagine you build a time machine, a device that allows you to travel back to any point in history. You decide to go back in time and prevent your grandfather from meeting your grandmother. If your grandfather never meets your grandmother, then your father is never born, which means you're never born. This creates a complex web of cause and effect that challenges our understanding of reality. If you're never born, you couldn't have traveled back in time to prevent your grandparents from meeting. This paradox creates a loop that seems impossible to resolve. It's a paradox that creates a logical inconsistency, a puzzle that has no clear solution. This is why the grandfather paradox is so intriguing. It challenges our understanding of time and causality. The grandfather paradox highlights the potential for contradictions if time travel were possible. It forces us to think about the rules that govern our universe, and whether those rules can be bent or broken. One idea is that time travel might be possible, but you're somehow prevented from changing the past in any significant way. This concept is known as the Novikov self-consistency principle, which suggests that any actions taken by a time traveler were always part of history. Another idea is that if you do travel back in time and prevent your grandparents from meeting, you create an alternate timeline. In this new timeline, you never exist, but the original timeline remains unchanged. The grandfather paradox forces us to confront the implications of time travel and the nature of cause and effect. It makes us question whether our actions are predetermined or if we have the power to change our destiny. It's a reminder that the universe is full of mysteries and that our understanding of time, fate, and existence is still evolving. The grandfather paradox is just one of many puzzles that challenge our perception of reality. Let's dive into alternate timelines and parallel universes. Imagine a multiverse, a grand tapestry of universes, each one a unique branch of reality. Every decision you make could be playing out in a parallel universe. The many worlds interpretation of quantum mechanics suggests that every time a quantum measurement is made, the universe splits, creating a new branch of reality. If this theory holds true, there could be countless versions of you, each living out a different life. Some physicists believe that if we could access these parallel universes, we could potentially travel between them. Imagine stepping through a portal and emerging in a reality where dinosaurs still roam the Earth. The possibilities are as vast as the cosmos itself. Let's grapple with the philosophical questions that arise when we contemplate time travel. If we could journey through time, it would challenge our perceptions of reality, free will, and the meaning of existence. One question is whether we have free will, or if our lives are predetermined. If we could change the past, should we? What are the implications of altering events that have already occurred? The possibility of time travel opens up a Pandora's box of philosophical dilemmas. It challenges us to confront our deepest beliefs about the nature of reality and the ethical implications of tampering with time. So, what would you do if you had access to a time machine? Would you travel to the past or venture into the future? Share your thoughts in the comments below. While these concepts remain largely hypothetical, scientific understanding evolves continuously. Time travel captivates our imagination and challenges our perceptions of reality. Stay tuned for more explorations into fascinating topics that shape our understanding of the universe. If you love fascinating trivia, don't forget to like, comment, and subscribe for more amazing content.